This short revision video is about series and parallel circuits and what happens to current and potential difference in series and parallel. So if we start off with a simple series circuit, so we can tell it's a series circuit because all the components are in the same loop. We've got one loop, and let's say that 3 amps is flowing down this circuit. 3 amps will be there, 3 amps will be there, and at any point in this series circuit it would be 3 amps because current is constant in a series circuit. However, if we look at potential difference in a series circuit isn't constant. It can split and it doesn't have to split equally. For example, if this cell is producing 12 volts, this light bulb may require 3 volts of potential difference. And if that's the case, we started off with 12, we've used 3 up there, so 12 take away 3, that means that light bulb would require 9 volts. So potential difference splits or is shared in series, and it doesn't have to be shared equally. But potential difference in parallel. So we've got one loop here, we've got a second loop here. Potential difference in parallel does stay the same. So if we've got 9 volts at that voltmeter reading, we've got 9 volts at that voltmeter reading. The reason why that is because our cell is producing a potential of 9 volts. So potential difference stays constant in parallel circuits. However, for current in parallel circuits, it is not constant. For example, this cell is producing 3 amps of current, so we've got 3 amps flowing through this ammeter, but we've got 2 branches. We've got one branch there, and we've got a second branch there. We've got one branch there, and we've got a second branch there. And in this first branch, if that ammeter uses 1 amp of current, this ammeter must have 2 amps of current because we started off with 3, one's gone down that first branch, the other 2 amps must go down the second branch. But these 2 branches merge back together, so that 1 plus the 2 merge back, and we get the 3 amps that we started with back at the start. Resistance in series is nice and simple. Resistance in series, for example, 2 resistors. We've got a cell there. This first resistor, let's say it's got 50 ohms, and this second one's got 100 ohms. The total resistance equals 50 plus 100 equals 150 ohms. So resistance just adds up in series. But resistance in parallel does the opposite, and you don't need to know the maths for this. If we've got resistors in parallel, the current's got more than one route it can take, so resistance decreases. Resistance decreases in parallel because there's more than one route. And that is the summary of series and parallel circuits.